In this video, we will discuss what queues are and how we can use them in VHDL with the VUnit verification framework. By the end of this video, we'll understand how to use queues to store and share data across processes in our test benches. A queue is a data structure into which data are pushed on one side and popped on the other side. Queues operate on a first-in, first-out basis, and like a hardware FIFO, we usually cannot access the elements inside a queue. At a minimum, a queue must support pushing data to it and popping data from it. In a push operation, the data is added to the back of the queue. Any existing elements inside the queue are shifted to make room for the new data. A pop operation works in the opposite direction. Data is removed from the front of the queue. Any remaining elements stay in their position as the queue shrinks. Queues are very useful for storing and sharing data between processes in a test bench. A typical use case is to save the inputs to the design under test in an input queue and the outputs of the design under test in an output queue. The test bench can then run a reference model that reads the data from the input queue, calculates a set of expected outputs, and compares them with the actual output values stored in the output queue. Unlike System Verilog, VHDL does not support queues natively. Luckily, the VUnit verification framework includes a queue data type and API to interact with it, so we don't have to implement our own. The function calls that we'll use most frequently when working with queues in VUnit are new queue, push, pop, isEmpty, flush, and length. Let's discuss each one with a code example. We start by setting up a minimal VUnit test bench. Then we add our queue signal. We also declare several variables in our main process to exchange data with the queue API. The new queue function creates the queue object that we will use. We must call this function before performing any other operations on the queue. If we use a signal to implement our queue, we must add a 0 delay after calling the new queue function for it to take effect. If we remove this delay, we'll get an error for trying to push data to a null queue. The push function stores a new element into the queue. Unlike System Verilog queues, a single VUnit queue can hold elements of different data types at the same time. The pop function removes the oldest element in the queue and returns it so that we can use it in our logic. The VUnit API also includes verbose versions of the push and pop functions, which we can use to make the type of the argument or return type explicit. Uncommenting the last line of this code produces an error because the returned type cannot be resolved correctly. The isEmpty function returns true if the queue is empty, and false if it has at least one element. The flush function removes all elements from the queue, leaving it empty. And finally, the length function returns the length of the queue in bytes. It's important to note that this length refers to the space that the simulator allocates to each element in the queue, and not the size of the element that we use in our test bench. For example, calling the length function on a queue with one integer returns 5 bytes, not the 4 bytes that we might expect given that an integer in VHDL is by default 32 bits wide. The same applies to logic vectors. The length of a 1-bit vector is 2 bytes, the length of a 32-bit vector is 30 bytes. In this video, we discussed queues, a data structure that we can use to transfer data between processes in a test bench. Because of VHDL's lack of native support for queues, we looked into VUnit's queue library and ran code examples for the most common queue operations in VUnit: new queue, push, pop, isEmpty, flush, and length.